In this video, we're going to finish our derivation of the maximum likelihood estimator for the population parameter P. And remember what P represents. P represents the probability in the population that a randomly chosen individual is male. And we reasoned that P would actually be the fraction of individuals in the population that were indeed male. But the problem here is that we don't have the entirety of the population, we only have a sample from that population. And we're trying to gain an estimate of P from our sample, and we're trying to do that via the maximum likelihood estimator P hat ML. And we're trying to derive this P hat ML term. And also remember that we derived this expression for the log likelihood. And remember, we could consider log likelihood because of the nice properties of log, because of the fact it is in fact a monotonic function. Okay, so the idea is that we're trying to choose P, or strictly P hat, in order to maximize the log likelihood. So what we're actually going to do is we're going to differentiate the log likelihood with respect to P hat, and then we're going to set it equal to 0. So if I differentiate with respect to P hat, what we're going to get is we're going to get P times x bar divided through by P hat minus n times 1 minus x bar divided through by 1 minus P hat. And we're going to get a minus here because of using the chain rule, because we've got a minus sign actually up here. When I differentiate that, I'm going to get a minus times the log, or 1 over rather, 1 minus P hat. So that's why we've got a minus sign which has come in here. Okay, and the idea with maximum likelihood estimator is that we're trying to maximize the log likelihood over choice of P. So I'm going to set the differential equal to 0. And if I take this expression over to the right hand side, so if we take that term over to the other side, what we're left with is n x bar over P hat is equal to n times 1 minus x bar, all divided through by 1 minus P hat. And because we've got n on both sides of this expression, we can just cancel it. And then what we're going to do is we're going to multiply through by the terms which are on the denominators of each of these fractions. So then what we're going to be left with is x bar times 1 minus P hat is equal to P hat times 1 minus x bar, which implies that we're going to have x bar times P hat x bar is equal to P hat minus P hat times x bar. And note that we have P hat x bar on both sides here, so these are going to disappear, and we're going to be left with P hat is equal to x bar. So our maximum likelihood estimator for the population parameter P just turns out to be the sample mean x, where x here represents the sex of an individual, and it's a dummy variable which takes on a value of 0 and 1. So the idea here is that we are summing over all n individuals, the sum from I equals 1 to n of xi, and then what we're doing is we're dividing that entire expression through by n. So what does this mean in practice? Well, it means that the maximum likelihood estimator for the population parameter P is just going to be the fraction of individuals who are male in the sample. And that makes intuitive sense, because remember that P in the population is just the fraction of individuals who are male in the population. So it makes a lot of sense that the maximum likelihood estimator for the population parameter P is just going to be the fraction of individuals who are male in the sample.